Hello, this is Sokobond. It's a game I've played before, but I'm gonna revisit it, I guess, just so I can do a full playthrough of it, because that series that I did, like, I only got up to like 3 complete worlds or something like that. So, yes, how Sokobond works is you act as a certain atom of a certain element, and your goal is to create a molecule by bonding with other elements. So in this case, I could do this to bond with oxygen, and I could also push other atoms. I can do that, and therefore bond like so. And this creates molecules. In this case, this is water, which is H2O, which consists of 2 hydrogen atoms and 1 oxygen. Water expands by about 9% with tremendous force when frozen. So yeah, okay, I'm gonna go... Oh. Alright. So yeah, it's basically a bunch of levels that focus on this mechanic of you being an atom and pushing other atoms around. So yeah, it is kind of chemistry based. You don't need to learn about the chemistry if you don't have to, but I think there are some levels where you do have to plan out your final molecule state, because there are certain options you can have. In this case, here you can see, okay, I cannot use my cursor over here because this game doesn't let me do that. However, you can see that each of the hydrogens have... Oh wow, it even tells me to reset. Each of the hydrogens have one of these orbiting circles around them. That refers to a something known as a valence electron, which is sort of the electrons that appear on the outside of an atom, right? So the electrons orbiting the atom, and the ones shown are valence electrons. Oxygen actually has 6 valence electrons, but it's only shown 2 because only 2 of them are, involved in bonding whenever a molecule is formed. So yeah, so there you go. By mass, humans are about 60% water, most of it in our cells. Oh, this level is called cell. Let's go. Alright, so we have a choice now. Let's say push. So now I'm acting as the oxygen molecule. Right, so each of those orbiting electrons basically indicates a possible bond to form with another element. So in this case, oxygen can form 2 bonds, while hydrogens can only form 1 bond each. Doing that is forced, but I can push stuff around like this. So that is basically what they want me to do. So push. The rings of Saturn are almost entirely made of frozen water, which in other words is ice. So yeah, alright, loop. Alright, so... Ooh, okay, we got an extra oxygen here. I think this will form hydrogen peroxide. Maybe. Right, oh no, it's a loop. Okay, so... I can do this, and I can do that to form hydrogen peroxide, which is H2O2. And what I did there is I pushed this block up to form a preemptive bond with the oxygen up there. So there you go. 1 liter of pure hydrogen peroxide can release over 300 liters of pure oxygen. That is... Yeah, I think that's true. I don't remember the math behind it, but yes, gases are weird. Alright, next, structure. Right, now I'm a nitrogen atom, and nitrogen can form 3 bonds. So probably what I would like to do is perhaps do this first and then form 2 bonds at once. There you go, ammonia. Your kidneys secrete ammonia to neutralize acid, because ammonia is a basic compound which neutralizes acids basically. Alright, chemistry lessons. Monty Hall. Right, Monty Hall problem. This is a reference to that one, the one where you have like 3 options. Which one is the logical one? I bet it's something to do with pushing. So I do this and push this out or something similar. I can push, I mean, I can go all the way over and continue pushing you, but pushing you up too high doesn't make any sense. Okay, what about pushing both, or pushing just this one? Yeah, I think that's better, in fact, because I can... Oh, but... Right, but... How am I going to go past you without blocking myself? Because I am now going to be a rigid block. So maybe not that. Maybe instead I do it on both sides here to allow myself to bond to the right and the left. There you go. Ammonia. 2/3 of all ammonia on Earth comes naturally from cows. Interesting. Alright, Lotus. We got carbon now, which can form 4 bonds. Do I want to do that? Or do I want to move to the right first? I feel like very possibly... Well, at some point I'm going to need to bond with something above me, right? Because carbon needs 4 bonds, so it needs to bond with one object per cell it's adjacent to. So, yeah, I don't think you can have any of the bottom hydrogens bond at the top. So it must be either this one or that one, which kind of shows that you cannot do this first. You have to do this. And by symmetry, I would assume that this is okay. I can do that because I'm going to bond with it at the top. So doing that is okay, I would guess. Oh, I don't know about that though. Do I really want to do that? Well, I mean, doing this will allow me to do that, right? And therefore I can move in here. Nice. Alright, methane. Methane was discovered by Alessandro Volta, who later invented the battery. Hence the term voltage, yes. Alright, not. Okay, so... Once again, the principal holds I need to bond something to the top, bottom, left, and right. And I believe that this is immediately dying because I can't move up and down to bond to my left and right. Again, by symmetry, I think bonding to any other one like this is just valid. Probably have to do this as well. Yes, and now I can bond to the top and bottom. Okay. Cool. Compost heaps can produce methane if they don't get enough air. That's why cows also produce a lot of methane as well. Coyote. Alright, lots of stuff now. So this might be where we want to plan our molecule better. Right, because nitrogen again can form bonds with 3 things. However, by forming bonds to all 3 of these, you isolate this oxygen which cannot bond with anything else. Oxygen bonds with 2 things, so it acts as sort of like something that can go between a bond. So rather than N bonding with H, it could be N bonding to O and then to H. So I guess a first step could be this. I don't want to do that because, yeah, bonding 2 hydrogens together doesn't work. It needs to be a single molecule. Does that work? Actually, yes, because I can do this now. There you go. Hydroxylamine. Yeah, it's called hydroxylamine. That's a really interesting name. I can see why though, because the amine is the NH2 group, and the OH group, which is supposed to be an alcohol, is actually called a hydroxyl group if it's not the main one. Alright, many integrated circuits in phones and computers were washed with hydroxylamine based cleaners. Not water, because water contains unwanted minerals which can damage things. Roadrunner. Alright, so it's about the same thing actually. It's just instead of 3H and 1N, it's 4H and 1C. But now I'm acting as the O, so it is going to be a little bit different. I probably want to... I mean, I have to do this first, right? Why do I do that? Oh yeah, I bond with both of them. I wonder if I have only one bond I can form. Which one would I bond to? Alright, so I think first thing I do is probably that. Does this... Wait, hold on. Does this ask me to reset? It doesn't. Wow, it doesn't consider this a fail state yet. But obviously, yeah, this is a fail state. Okay. Maybe I want to do this so I can push stuff down. What would you bond with? Oh, okay, you don't bond with the other H first. You bond with the C first. Cool. I can probably do this and then bond with other stuff. Yeah, and this is classic alcohol, methanol. Methanol is also called wood alcohol or wood spirits. I wonder why. Alright, so we have this and we have that. I don't know which is better, but we unlock this first, so let's go there. Split. Right, this one. This splits up a bond, which is why this is not considered a fail state. So I can do this and I can move the H over to the corner first before grabbing the oxygen. Torn apart, learn how to separate 2 bonded atoms. Cool. That was a Steam achievement. If you're careful, pure distilled water can be cooled as low as minus 48 degrees Celsius before it freezes. Wow, did not know that. I believe it might be based on pressure, because the freezing and boiling points of water are actually not constant if your pressure is varied. Alright, lock. That's actually a more physics thing, but okay, lock. Right, I can't get up here, so I need to somehow break off like that. I have to bring you in. Doing this doesn't let me go back in, so I have to do this first. And hopefully moving left here will form 2 bonds at once. Yes, it will. Okay, of the 4 classical Greek elements, water is the only one we now know to be a single chemical compound. Right, the others were air, fire, and earth, all of which are... Well, fire isn't even a compound, but the others are combinations of several of them. Right, out of reach. Cool, alright, so I want to jam nitrogen into the corner first so I can get... Oh, yeah, what do I do here? Because doing this does not let me get back out. And looks like I always bond with the one on my left. Yeah, it's always the one on my left. Alright, so I need to somehow make it so that I... What? Oh, it even shows you a replay. I need to somehow make it so I have nitrogen on top of me so I can push that in and do that. So, is this good? Yes, it is. Okay, there you go. Ammonia. Nitrogen is necessary to create the basic building blocks of life. That is true. Alright, small key. Oh, I see. It's because the map looks like a key. Alright, so we got a bunch of unbonders here. I don't want to do this. Right, the thing is, once I... You know, if I could get in, I can't get back out. So I need to form the molecule right there and then, which implies I need a straight horizontal line of atoms here. So like this would work. Cool. Ammonia is a gas at room temperature, but it dissolves in water. Does it? I don't remember. Okay, push up. Or push up. Right, pushing up forms this bond. I don't want that. I want again hydrogen peroxide. So I have to move you away first, maybe? Can I push up like this? Yes, I can. And in fact... Oh... Right. So this is definitely just horrible. Can I do this? That's sort of okay, but not really. I don't wanna do that. Okay, I'm stuck in a loop now. How do I break this loop? I'm gonna restart. I'll get you out of the way first. That's not good. I want it to be the opposite. There we go. Wait, no, it's not. I mean, that's close. I think that's it. Yeah. Okay, that was a bit jank, but I think we got it. Hydrogen peroxide slow breakdown is how glow sticks can glow for so long. It's also why you shouldn't eat glow sticks, because they contain hydrogen peroxide. And hydrogen peroxide is actually really, really bad for you. Alright, anxiety. I don't know if you've seen this video of like that one guy pouring hydrogen peroxide on his wound. That was very likely just a traumatic experience for that guy. Alright, so again, hydrogen peroxide. Let's see if I can just finagle my way over. I need an oxygen here. I can actually pull you out. So maybe I want to push you up here. Yes, there you go. Hydrogen peroxide. Bombardier beetles use a hydrogen peroxide jet to release toxic boiling fluid at their enemies. Yeah, more evidence that it's not good for you. Alright, Wingman. Okay, Wingman. Why? I think this is it's methanol, right? We've seen this molecule before. Okay. So what do I want to do here? We have a unbonder over here. So maybe I want to like grab all of them and kind of move them in like this. I can push the carbon around now with the extra hydrogen that I have. I can even do this and then use this as a block. But I mean, it's not really required at this moment, right? I can do this and it's almost stuck until I unbond and then rebond like that. And I can just repeat that for all of those. Probably want to break you first. This is fine. Yeah, and I can form bonds over here. I can form a bond down there. Can I bring you back out? No, I can't form any more bonds with you. So before that, probably what I want to do is to grab... Oh, that's clean. Can I make it through this? No. Unless I did this. It's basically as bad. Alright. This is very jank, but I think we can sort of finagle our way through this. So like this, this is almost what we want. Very close, very close. Is this what I want? I need something to be on my right. Right, so this. There you go. Methanol is the most elemental of the organic alcohols. Yeah, it contains only one carbon. Technically, alcohols can have as long a carbon chain as they want. But yeah, one is the least they must have. Breathe. No, we don't do that yet. Let's do ring. Oh, alright. Lots of O's here. So ring. How do I want to do this? Right, because every element must have two bonds, the only way to do that is to form a ring. So I gotta somehow try to make that happen. So doing this forms a third of the ring. So if I could do this, pull you over. I can't push you down because that would break. Could do a lot of random stuff though. Is this good? It is. Alright. Tetra oxygen. Okay. Tetraoxygen was predicted in 1924 but only discovered much later in 2001. Cool. Cottage. Got a nice little cottage here. This one is the hydroxylamine thing that I got a bit confused by that. I can go up and move you away first, but I can pull you back down, yeah, so. I mean, doing this gets us stuck immediately. Although I guess this might be okay. And then, yeah, this one is like... Oh, is this good? Oh, that's just it. Alright, cool. Biologists have used hydroxylamine to randomly mutate DNA. That does not seem cool. But, okay, we got more worlds to go, but let's keep going. Hanoi, Anvil. Let's go Anvil first. Right. So we need to bond... well, it looks like all we need to do is to bond the two nitrogens together. But of course, we'll get stuck in the process. So I think I probably have to move this over. Or something. Then do that. Oh, that looks good. And then come back, bond up, and then go in here. Nice. Hydrazine. Yeah, hydrazine. Oh, this gives me flashbacks of my A-level chemistry. Hydrazine is used as rocket fuel, including for the Curiosity rover. Awesome. Alright, Hanoi. Classic Tower of Hanoi puzzle. You're gonna get stuff over. More hydrogen peroxide. So this one, well, that's sort of bad. I can't pull you out because I would have to break you eventually. So we start with one of the oxygens first. Doing this allows me to go over. Is that okay? I mean, I can push you back to here now if that's useful. Maybe that is useful somehow. I can do this. Yeah, I can do that now. I can finish the entire thing over here. Interesting. Hydrogen peroxide. Dilute hydrogen peroxide is used to bleach hair and laundry. I think it's the main compound in bleach as well. Actually, I have no idea though. Is it? I don't remember it being that. But alright. Trap. Alright, what is the trap here? That's the trap. I can't move left here. So what I need to do is I need to be able to not make a bond, which means I need to have a full compound by the time I reach that. Okay, understandable. So I need to push you down. I could probably move you over. And then repeat. Well, this one's a bit tough because how do I... maybe like this first and then get you on that side. Never mind. This is actually a bit tougher than I thought it would be. Is this okay? I don't know. I don't think so. Oh, no, there we go. So now, here we go. This is a bigger trap. What do I have to do? I have to push in nitrogen. Right, okay. So let's get everything out of the way first. A lot of stuff here we can undo if you want. Because there's so many of these. It's not very easy to get stuck here, so... It's very easy to get yourself into a loop that, you know, you can't escape. So something like this would happen, but I need... Right, I need another hydrogen... I need another hydrogen... down here. So that I can form 3 bonds like that. There you go, more hydroxylamine. It's a different shape now. And I think that has like a concept to do with like what they call isomers, I think. Anyway, hydroxylamine can explode when heated, but nobody is sure why. Dangerous. Alright, new world. Plunge. Let's go do this first. I think the next one we unlock. Then after that we unlocked green, then cyan, and then maroon or brown or something like that. Feels like this might be a darker color of... Yeah, every single world has a darker color. Like you see on the right, there's a darker green arrow, and here there's a darker blue arrow, and then they kind of merge to form a sort of turquoise, teal, Hatsune Miku, Parrot the Platypus kind of color. I don't know what I'm saying. But okay, I think this might be challenge levels then, if I remember right. Yeah, because absolutely no new mechanics yet. It is just harder levels. So should I go for this first, or should I just go for the rest first? Let's go for the rest first. No, let's go for the harder levels first. Okay, hydrogen peroxide. Now we cannot break bonds here, so we have to choose what we do very, very well. Okay, no longer tells me to reset. So, obvious choice would be this. Doing this seems bad, even though maybe not. I can push this down as a result. But is that good? I can now do this, but that forms your product. It must be something like that. But now I'm stuck. Okay. Another thing I could do is this. I can push stuff around as a result. But I don't think that's useful though. Maybe I do the same thing but with this oxygen over here. Slightly better because now I can form this S shape. Cool. Paper is naturally brownish. Hydrogen peroxide is one of the several chemicals used to bleach it whiter. Interesting fact. I did not know that. Alright, chimney. Alright, we have a chimney here. Whoa, 2 oxygens and 1 nitrogen. How do I make a molecule like this? Right, symmetrical. Could probably do something like... Well, I eventually need to come up to the top though. So how would that even work? Well, that would work if I could do this. Push it up. Nice. Sorry. Wait, what? Is that really what it's called? Bis-hydroxylamine? I thought it would be called like dihydroxylamine or something. Because that's a general prefix that chemists use. But I guess it's now called bis-hydroxylamine. And not di, apparently. Anyway, bis is Latin for twice. Which, yeah, we have 2 OHs, so bis-hydroxyl. Cool. Scoop. Alright. Oh, okay. Classic methane here. We cannot touch any of the hydrogens. So the first thing we have to do is we cannot escape this without touching hydrogens. We have to touch carbon like this. Okay. So once again, we need something to be... Ooh, wait, hold on. We need something to bond at the top. How will we do that? Bonding with any of these from the bottom prevents us from pushing anything upwards. So we can't do that. Instead, I believe we... Yeah, probably push like this, right? So that we can scoop this and push it upwards. There you go. Cool. Methane can explode or suffocate people without warning. That is quite sad. Yeah, it is. Well, most organic chemicals are flammable, I think, just because they have carbon in them. Heart. Alright, yeah, this is a heart. Alright. If I bonded them both to the sides, I cannot get on top of it to reach the top of the carbon. So my guess is one of them has to be on the top. But being on the top of any one of them, what would that require? I don't know. Okay, well, something I could do is I could push it down by doing something like this. Is that good? I could do that, but now I'm stuck in place. Could push you... do I want to do that? Could push you further down. Oh, I can do this. I don't know why I didn't see that, but there you go. Earthquakes can release methane into the ocean from undersea reserves. Alright, these facts are getting kind of not fun anymore. Like, there's still cool bits of interesting pieces of information, but no longer the fun stuff where it's like, hey, did you know that this was discovered in what year? Alright, what else do we have? Chandelier? Oh my, what is this? It's a lot of carbons. Yes, to not... Oh, wait, hold on, question. Does this form a bond with hydrogen first? No, it forms a bond with whatever is not hydrogen. Or rather, it forms a bond with whatever does not cause a death state, I think. Alright, so I can form this horizontal. I can form it vertically as well. But like, this is obviously... Oh, right, I can only form one more bond. Right. Interesting. Well, how do I want to do this? If every carbon bonds to 4 things, do the carbons have to bond to each other? Like that? I mean, that allows for some really interesting movements. Yes, wow, look at that. What is this? Oh, it's ethanol. Right, the lethal dose of ethanol is 5 grams per liter of blood, which is actually a lot smaller than people might think. I think a liter is like, what, a kg of blood, essentially? That's not really a kg, because blood is not the same density. If it's in water, then a liter is a kg. But it will be kind of close to that amount. Alright, next. Block. I think we open this one afterwards. Oh, we don't want to do that, do we? So, okay. Classic nitrogen. Do you bond? Yeah, you bond with nitrogen first. Okay. So, to form a bond with nitrogen, or to form a bond with the top hydrogen, what do I need? I need nitrogen to either be on the left or right of the hydrogen up there. So doing this kind of fails immediately, because hydrogen can never bond with the one on the top anymore. Doing this appears to be okay, although like doing this would fail as well, so we're doing this. So maybe I don't want to do that. Maybe I want to do this first. How would that help? Again, bonding with something above it is not good, and like I can't really push it either. Can't move up because that fails. Really? Okay. Is this okay? No. This is not okay either, because I can't move out anymore. I think this is the one I did get stuck on quite a bit. That's something I didn't see. I can push you out, that's what I can do. There you go. Nice. Ammonia can be found ammonia can be found on Jupiter, Uranus, and even Pluto. Sweet. Yeah, that's a fun fact. Okay, factory. We gotta create diazine. However you pronounce it, you gotta create that. So how would I do that? I feel like it's something like this first, because I want to do that, right? Why is it I can push that entire thing up? Is it so I can do something like this? So like, why is that useful? That breaks the entire symmetry. I don't know if I like that a lot. Okay, if I made you vertical, I can push stuff around like that. Why is that useful though? Like that just kind of fails because nothing can really hit that hydrogen anymore. Okay. It has to do with pushing, I bet. Which is kind of obvious, but you know. Is this good? Almost. Not quite. Right, that's because I generally want to push the nitrogen upwards, even though it's not as simple as it looks. So like, do I want to do this instead? Maybe that's okay. No, I kind of get quite stuck doing that. So maybe this instead? Is that okay as well? Maybe. No, it's pretty close, but not really. Do I have to maneuver you guys then to do this first? This kind of this is kind of even worse. Okay. don't know if I want that. Alright, this isn't working out. Let's see. Like, this is a plausible step, because I can now push it around. Maybe that's what I want. Maybe? Can I do this? Isn't this what we didn't want though? Is there any way to not have this happen? I was like, can I get back from here like this? But sort of, not really though. I get kind of stuck over here. If I push you, if I push you up, the only way I could push you up is if I bonded with you first, which is kind of bad. I don't want this to happen. That was close, but not it. I can also push you up like this. That's all I can do. Oh, can I do this now? Yeah, and I form one bond here and one bond here. Alright, hydrogen has been used as a fuel for the US Army's liquid-propelled artillery. Interesting. We have gray. Oh, helium. Cool. What else do we have? Creature. Right, it's got a skull. The map is a picture of a skull. What do we have to make here? Methane, right? So same rules to apply. One thing on top, one thing on each side. So maybe like this. Oh, that gets us stuck, right? It's like I want to do this first, but by doing that, I can't really make a bond unless I push the object down first. So down you go. Form a bond like this, form a bond above and then below. Nice. The Hubble telescope has seen a... Oh wow. The Hubble telescope has seen methane in the atmosphere of a planet 63 light years away. Carbon. Rosie. Alright, ring around the Rosie. Is this ethane? Not methane, but ethane with 2 carbons. I believe it is. I think... I mean, I can't really prove anymore, but in ethane, the carbons form 1 bond with each other and then 3 bonds with hydrogens each. Which do in fact have to form some sort of like shell of hydrogens around you. So it's always gonna be because each of the carbons once again has to have something above, below, and to its left and right. It's still a principle that yes, you do have to have something above and below you and something like that. If I want to push first, but I don't want to push that much. Maybe I could do something like this. Maybe that's good. Maybe. Now, how do I have something below me? This all feels really bad. How do I have something below me? Do I have to do this first? I can do that as well. Maybe that's okay. I mean, that is also okay. I want to do that, I think. Now I'm kind of stuck, but could possibly move over. I need something to be above me, so like this is good. There you go. Alright, ethane was first produced in 1834 but was mistaken for methane. Yeah, they're very close in structure. And therefore also very close in chemical properties. However, one way to test it out is by melting points, because they will have different melting points. Anyway, Kruskal. Alright, what do I want here? Looks pretty... Oh, it's a diol, or 2 alcohols. So like this, and then form 2 more hydrogen bonds. Alright. Is this not a good idea? Again, something needs to be below hydrogen. So maybe this first is good. That looks okay. So I can do this. Almost. That? That's not quite. We have to move some stuff around first before I come back. Is that okay also? Yeah, that's technically okay actually. This is a very weird structure. I don't know if that's plausible. But this is not something I think I've ever seen. It is not, in fact, a carboxylic acid because that's not how carboxylic acids look like. But, I mean, it could be a thing we're supposed to make. At this point, though, this carbon cannot bond to the right of this hydrogen, though. So maybe I do stuff like push stuff around, and maybe that's okay. So like this. Is that okay? Yes, wow, it is. There you go. Yeah, methane diol. So methane, but 2 of the prongs have been replaced with with alcohol groups. Astrochemists want to research for signs of this substance in faraway stars. Yep, yes we do. Okay, so that's all the... Cool, well, that's a lot of levels completed so far. Let's keep going. Hopefully we have time for this. Alright, challenge red levels. Plunge. Okay, I can go all the way here. I can't move after this point though, so what I want to do is I want to push carbon in. Like, how do I want to do this? Move. Yeah, I'll do something like this, you know. Something like this, and that will form what I need. I also want carbon to be behind me to form 4 bonds with the hydrogens. Maybe. Yeah, that seems right. So let's see if I can set that up. So I want a hydrogen. Oh, this is kind of bad. Oh no, it's fine. So like this. There we go. Yep. All right. Boom. Alright, this is not something I've seen before. Dimethyl ether. Okay, I've heard this in my lessons, but I don't think I had to figure out what this does. This makes high pressure bubbles at room temperature, so it's best used to power aerosol cans. Nice. Cool. Compass. We do in fact have a compass. We want... What is it? Hydroxylamine again? To pull you out. If I can pull all of you out, except the bottom one I cannot pull out. So I want to do this first. I want to break you and then form that over here, but not quite. I want to form that and then that and then that. Alright, there you go. Hydroxylamine is an unstable white crystal that will melt on a hot day like ice cream. Don't eat that though. Do not eat hydroxylamine. Blocking the way. What is blocking the way? This. Right, so I need to break that bond. However, how would I break that bond? Because pushing you all the way out prevents me from going behind you. So I need to store this oxygen somewhere else useful. So maybe here. So I can push you and do this now. But now, oh, whoa. Okay, maybe this is fine. Maybe I can do this. Oh, nice. Wow, that just did it. Okay, touching hydrogen peroxide will turn your skin white temporarily. Yeah, it will also do a lot more than that, I think. Honestly, I have no idea. What is that? Wait, look at that. Hold on. That is an abomination of a molecule in that preview. Power. Why is this power? Does it look like an electrical plug? So what do I want? Maybe I want this? Somehow? Is that good? Not really, but I can get somewhere close by doing this instead. No, I can push up now. I'm gonna get rid of the hydrogen that's in the way. So what? How do I do that? I can do this. But, oh no, this is still, this is kind of not fine. Yeah. Okay. But maybe that was kind of close. What do I want actually? Do I just want to bring you out as well? Yeah, possibly what I just wanted was to bring you out. Okay, this is also stuck, I think. Unless I did this first to bring you out. This feels kind of bad. Maybe that's better. I mean, I guess it might be a little bit better. I don't see much of what to do here, so I guess not. Alright, back up. Got a lot of choices to work with, but maybe bring out that hydrogen was also a good idea. Yeah, maybe bring out the hydrogen was a good idea. I can do this now. Oh, right. Interestingly, I don't make a bond with that. Can bring you out. I think this just does it. Nice. Hydrogen peroxide can power a rocket all by itself. Really? I thought I would only be like really slow as a result. Grater. Okay, yeah, we start as this huge thing over here, but we need to grab onto that thing over here. So we're basically breaking down the compound and then building it up again. This is a monstrosity of stuff. Like, what? So much stuff is going on here. Can I figure out what's going on here? When I move left, the top hydrogen moves right because I'm pushing it, but it breaks, so it doesn't push the rest of it up. In the meantime... Wait, really? Hold on. Look at this. Yeah, look at that. The middle CH bond does not break because the H behind that is pushing it in, which reforms a bond. Wow. Okay, this is actually really broken up. So let me just try and break everything again. I forget what the ultimate thing I want is, but hopefully I can kind of just trick my way into like fixing this up. Nope, I'm getting further and further away from building a logical compound. Okay. No, I don't want to do that, see. So maybe doing this is better. Oh, but now H is built over there. Is this any good? No, I don't want to build H over there. I don't want to push you somewhere else first. Is that good? Sort of. The C is now very broken. I don't want to do this. Yes, there you go. Propanol. Geez, alright, this is just an alcohol with 3 carbons instead. Propanol is used in the manufacture of many cosmetics and perfumes. Cool. Around. What are you? Right. So this almost instantly guarantees I make a bond first. I can do this though. Maybe that's good. I need to make what? Methane again? Alright, this thing is completely stuck. I cannot break it ever. So probably what I do is push like this maybe? Is that good? I don't know. I mean, it looks okay. In fact, it might be okay. Actually, I don't know if it is. Oh, lots of moves here I'm just not thinking about. But this could be fine. That. Nope. Okay, all of this is really bad. I need something to be below the carbon. Right, so something needs to be below the carbon, which is very interesting. I need to push it upwards then. So I need to do this and then push you up. Yeah, and get out of the way. But doing this will cause H to kind of die. So instead, I probably have to do this to get you out of the way. Is that okay? I mean, yeah, I kind of did a lot of stuff as a result. Alright, I don't know how they decide which one bonds with it, but I guess we're going with this one. That's kind of bad though, isn't it? So how do I get this one out now? I have to... That looks rather okay as well. Oh, nice. There we go. Alright, finagled my way to the end. Food thrown into landfills is eaten by methane-producing bacteria. I think that's not good. I think. I don't remember. I think methane is like a greenhouse gas. Alright, station. More methane, huh? Okay. So let's see. I can push you out first. I can break this bond over here if I need to. Which is... Oh no, there is no break bond there. There is this over here though. Which could be a good thing, yeah. In fact, I think it might be. I could just walk back into here with a 3 long if that ever had to happen, but Right now I don't think it's possible. I want to keep making bonds. Is it even possible to break the... Oh, I'm H. I just realized I am H, not C. So I can walk off like that. Okay. Right, so do I set everything up again? Like that? I mean, that breaks it apart. That is not what I want. Yeah, that is not what I want at all. I'm just randomly trying to figure this out. That feels maybe slightly better, in fact. Yeah, I think that is just good. Okay. Nice. 2/3 of all methane on Earth comes from cows. Have we not seen a fact like that before? What? Okay, this doesn't show me the fact until I actually... Alright, fine. Infinity. Infinity why? Oh, it's just because this thing looks like an infinity symbol. I suppose so. I suppose so. Okay, doing this is absolutely terrible idea. I'll have to break it at some point anyway. So maybe something like this is okay. Yeah, if I can do that. Is that good? Yeah, maybe it is. Basically what I want to do is I want to... What do I want? I want to get hydrogen to do something funny like that. Yeah. So hydrogen does something funny. I can push it around. I have to get it out of the way though, so maybe something like this is okay. Yep, there you go. The atmosphere of Uranus is 2.3% methane. Fun fact. Windows. Right, so we have a bunch of windows over here. I need to form NH3. How? What? Okay. I think this was also one of the levels that gave me a lot of trouble. See if I can do anything here. I can bring stuff in. Do I want to bring stuff in? Do I need to push... Yeah, do I maybe need to push stuff down like so? And then I need to change the orientation, so I'm now doing this. Almost. It is simply that by moving down here or moving down here I would reform a bond, which doesn't let me do that. Alright, I can fix that though, because in the previous state I could also have moved down to push you out of the way first. So not too challenging of a dilemma. There you go. I think this is the first level I've actually thought about, like my plan of how to go on. Careful, ammonia is caustic and can chemically burn you. Yeah, as opposed to physically burning you like fire, it will react with your skin and make it very uncomfortable. Arena. Jeez, alright. So, we got a huge arena over here. What do I want? What do I want? I'm acting as oxygen, and I want... I think I want a diol and ethane diol. So 2 carbons is ethane, 2 alcohol groups is a diol. This is gonna be very, 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 very janky though. Like the way I'm moving stuff around. Because I want a diol, I don't think I want to bond 2 oxygens together. Okay, let me just see if I can finagle my way to this. Can I push you over? I can. I think we're sort of close. Maybe? Yeah, I can sort of maneuver. Okay, like in the micro scale, I can maneuver myself to change my own shape, right? And I can do this, right? And wait, hold on. Something is not right over here. Because now, yeah, one of them doesn't form enough bonds with each other. And apparently you can't form double bonds here. So, no, this is not what I want. In fact, yeah, I wouldn't have enough hydrogens to make ethane diol anyway. I need to have oxygen be in the center. Okay, so how do I break this? This feels like a bad idea. Maybe it's not. Can I? Oh, please don't do that. Can I? Can I break like this? There you go. No, I need to do that. Okay, it's getting very, very janky. Okay. Can I keep pushing you? I feel like that's not a good idea, even though it could be a good idea. But just push you down, push you over. This looks okay, except no, we're still missing a bond. Does oxygen need to be between them both? No, right? No. It's a loop or something. Yeah, it has to be a loop or something. It has to be a loop of sorts. We don't have enough hydrogens otherwise. Right, because of that one principle in chemistry class. Oh my goodness, I'm doing this all over again, am I not? The idea is if you don't have enough hydrogens, you either have more bonds or you form a loop. And because we cannot form more bonds besides single bonds here, it has to just be a loop. Okay, understandable. So, possibly what we have to do is a loop that looks like what? Like this. That's a loop we can form. And then each carbon bonds to two other things. Okay, and look at that. Very interestingly, right? If you're a loop, going through this basically preserves the bond because you're pushing both objects up. So the bond remains. So that's really interesting. I can kind of therefore just kind of do all of this stuff. There you go. Nice. Okay, dioxetane. Dioxetane derivatives make fireflies glow. That's cute. Two more. Do I want to do two more? I could probably do two more. Home. Actually, no, I don't think I'm doing two more. I'm gonna end the episode here. We'll finish those two off next. Long legs. We'll finish those two episodes off next episode. What? No, we'll finish those two levels off next episode. But yeah, this was pretty fun. I love getting back into this game. I don't know why. Doing all the chemistry just makes my brain feel useful again. But yeah, hope you enjoyed this video. I'll see you guys next time. Bye bye.